Good morning, good evening to everybody at ETHOS. My name is Mouhsine Serrar, and I'd like to introduce my colleagues, Dale and Jiddu. We are Practi. We have been developing and manufacturing cook stoves since 2008. Our presentation is about stove testing standards and specifically testing challenges faced by stove manufacturers. Today, we will focus on one issue of emission testing. We'll present results and learning from testing the Practi air tray. Practi has been working on air tray design since 2018. The first concept, an air tray module for Practi stove, was developed by Aprovecho. I'd like to take this opportunity to thank Aprovecho for a superb innovation. This is an air tray user in Tamil Nadu, India. Our first thought was if an air tray can make a Practi stove work better, then it can make other stoves better. Including making traditional mud stoves and three-stone fires better. We could then get a tier 3 to tier 4 performance with the cost, usability, ease of dissemination of a traditional stove. Developing an air tray for traditional stoves, mud stoves, and three-stone fires has been our focus since 2018. Next, Dale will present learning from our air tray testing.
This is a top view of the current design. It has 46 2mm holes covering an area of about 75 square centimeters. Here's how the air tray goes into the simulated mud ring stove. The fire bricks are high density, not insulative. Here's a still of the system in use. Large pieces of wood are easily accommodated. Now I'll show two short videos showing first the lighting qualities of the air tray, then the burning and rekindling qualities. The first video has the air tray off at the start, then you can see when the air tray comes on. Fan on. To drop below the boiling point, so this much flame is not enough to maintain boil. Notice that the white smoke is mostly being pulled into the flame zone. And that you can simply push in the wood and the fire easily reignites to a large flame. There are big differences between a standard emissions test and real stove use. The standard test is designed to be repeatable, and it's fairly good at being repeatable, but there are many differences, only some of which will be discussed here. One big difference is that in a standard test, the fuel is what I call nice fuel. It's small, uniform, dry, and straight. There is no restriction on how the fire is tended, and the best way to get low emissions is to use a fire of constant size, not too big, not too small, tended frequently. In a real cooking event, the fire is typically tended infrequently, which means sometimes it's too big. Also, the fuel is not nice. It looks more like this. It's not uniform, may or may not be dry, it's generally large, and occasionally full of ants. The fire starter in a standard test is small and dry, as seen here, and often alcohol is used as the starter to keep particulates down at the start of the fire. Here's a carbon monoxide production graph from a standard test. It's spiky, but never very high, and the total CO is below Tier 4 limits. The corresponding graph for particulate matter is now here. It's similar. It's also spiky, but the spikes are low and the total particulates are below Tier 4 limits. Here by comparison is the CO curve for the real cooking test overlaid on the standard test. Both curves are spiky, but the real wood test is much higher. Now here's the same graph with some notes about what was happening with the fuel. Almost always, the spikes occur when the fuel is fed into the stove. The standard test minimizes CO by feeding the fuel only in tiny, frequent increments. Looking at something similar for the particulates, here's again the standard test and the real test. You can see that in the real test with its rapid start, there's a massive PM spike at the start. Actually, this one is unusually massive since I used smoky pine cones as the fire starter for this test. Then after the massive spike at the start, the air tray produced very low PM for the remainder of the test, actually lower than the standard test. Here's a blow-up of the first 3 minutes of the real fire test. You can see the massive spike again, but also that the massive spike was reduced greatly when the air tray was turned on. The standard test keeps particulates small with its moderately low, moderately slow lighting and tending of the flame frequently. In general, the air tray produces low particulates under nearly all conditions, except during a bad start. The CO production for the air tray is heavily dependent on how the stove is fed, producing low CO under standard conditions, but higher CO under more realistic conditions.
As you may agree, there is still a lot of work to do to make stove testing more consistent, more practical, and more representative of performance in the field. There is also work to do to disseminate and to continue developing our air tray concept. We're looking for collaborators, both individuals and organizations. Let us know if you are interested. Thank you.